Welcome to this lesson where we're going to talk about our same hyponatremia patient, and this time we're going to try to figure out whether we can give 3% saline to correct her hyponatremia. So let's go over the patient again. This is the same patient that we've looked at in the last two lessons, a 70 kilogram female who has a serum sodium or plasma sodium concentration, of 110 milliequivalents per liter. But she has seizures, and we need to correct her hyponatremia. We've got two choices. We can either use normal saline, which we did in the previous lesson, or we can use 3% saline. And our target, regardless of what method we use, is to get to a concentration of sodium of 120 milliequivalents per liter, because we feel that at this level she'll stop having seizures. Now, we calculated for normal saline in the previous example that the patient would need approximately 10.3 liters. And now we want to know how much 3% saline would the patient need. And we're going to do some of the same calculations, if not identical calculations. We'll just add one extra step to this particular example. We said that when we give normal saline, we're giving approximately 154 milliequivalents of sodium per liter of the normal saline. But this time we want to give 3% saline. So this ratio is going to be different. 3% saline, very simply, is 3 times normal saline, which is about 3 times 154 milliequivalents per liter. But keep in mind that normal saline is 0.9% sodium chloride, so we divide that by 0.9. This is a percent, and so is this. So they cancel each other out, and what you get is about 513 milliequivalents of sodium per liter. That's how much sodium is found in a liter of 3% saline. Now we're going to take this number and do the same calculations that we did in the previous example, keeping in mind that when you give 3% saline, you're not only giving water, you're not only giving something that changes the denominator, but you're giving sodium. So you're going to be changing the numerator and the denominator. So in the numerator, we're going to have the total body sodium, or the total amount of sodium in the patient. And that's simply her total body water times her current sodium concentration, which is the 110 milliequivalents per liter. And what we'll get is approximately 3,800 milliequivalents of sodium. To this, we're going to add the salt that comes in 3% saline. Well, how much? And that's what we want to know. So we do 513 milliequivalents of sodium per liter of a 3% saline bag times X, which is the volume of 3% saline that we're going to administer. But we're also administering water to this patient. This patient already has a certain amount of water. That's the total body water, 50 or 60% of her weight. To that will be the amount of normal saline, 3% saline that we've added, and that's X. And all of this is going to equal the desired concentration of sodium that we pre-specified, which is about 120 milliequivalents per liter. So if you work through this and solve for X, here's what you'll get. Less than a liter of 3% saline is required to get this patient from 110 milliequivalents per liter to 120 milliequivalents per liter. vastly less than the 10.3 liters that we saw for normal saline. This is why 3% saline or hypertonic solutions are so valuable in patients who have symptomatic hyponatremia, because number one, you need to get their concentration of sodium up quickly, and number two, you need to do it with the least amount of volume possible. And that's best achieved when you pick a hypertonic solution like 3% saline. It's much easier, much faster to give 890 mLs of 3% saline than over 10 liters of normal saline in the same period of time. And so that's why we prefer to use hypertonic solutions to fix patients who have symptomatic hyponatremia. Many medical students and residents are worried about administering 3% saline because they're afraid that they can bring the sodium concentration up too quickly and then cause hypernatremia and problems in the other direction. Well, now that you know how to calculate the approximate amount of 3% saline you need to administer, you'll have a better idea of how often to check your serum sodiums and at what point of volume administration should you see the desired sodium concentration. And so this example is very similar to the previous example with normal saline, but I hope it highlights the importance of hypertonic solutions. They seem dangerous and they're a little scary to use, but when you go through these calculations, you'll have a better understanding of how much to give and how frequently to check serum sodiums so you're not overcorrecting. That's today's lesson. Thank you very much.